Probability. Ooh, is this the one that has all sorts of things in it? Oh, you are very fortunate because there is 8,000 notes I have to take. You might want to prep yourself. Which has its good points and its bad points. So, good point or bad point, you have to sit and listen and be bored for a long time. Good point?
If we get to learn, that's a good point.
Thank you, Caleb. I very much appreciate
Are
that.
we still boring and listless and
Well, I can't change your boring and listless.
You
Listless.
like seven.
That's just the way you are. Probability, ladies and gentlemen, is, anybody want to jump on that bandwagon? Probability is the likeliness of something happening. Probability, boys and girls, is expressed as, anybody feel free to help me out, expressed as a fraction. Probability is always given in fraction form, and that is relatively important for you today. Now, here is the deal with the probability. If we were drawing probability on a line, which we don't, but the book likes to do it, so I do it as well. Okay, if it has a 0 probability of happening, which is a fraction, okay, a 0 probability means that something is absolutely positively impossible. For example, the probability of 7th grade not being dull, listless, and drab, 0. On the other side, if a thing has a probability of 1, it is certainly it is. I like how Nathan looks in the book. It helps me out a little bit. Oh, it will happen. Probability of today, the day of the week ending in Y. Then you split that in half, children. Here is 1/2. Okay. If it falls down here, if it's less than 1/2, we call it unlikely. If it's greater than 1/2, we call it likely. And if it is 1/2, we call it as likely as not. This found right out of the book. Did I get most of that just like the book has it? I didn't really look, but after doing this for as many times as I have, it is. Got it? Nailed it. Good. Now here's an example. Take a look at the recent unpleasantness. Let's say you've got a spinner. Actually, I do have a spinner. Should I get a spinner? Should I worry about the spinner? Just draw one. Who wants to go there? Sometimes you do. Let's say you've got a spinner. And this spinner is cut into fourths. And the spinner is labeled A, B, C, and D. Here we go. If I asked you the probability of spinning a B, by the way, the capital letter P, math a lot of times stands for probability. Put parenthesis what you're talking about, what you want the probability of. Probability of the letter B would be, on the bottom is total outcomes. And on top is how many there are, the ones you want. So in this case, how many total outcomes are there? There's 4. How many 4s are there? Liv?
how many bees?
Does that mean how many B's? Yes.
1.
1. So your probability of a B is 1/4 in fraction form. Another, for example, if I asked you the probability of drawing the Jack of Hearts from a deck of cards, you'd have to have some knowledge about cards. How many cards are in a deck excluding the unfair jokers, Chase?
52.
52. How many jack of hearts would there be in a deck of 52? Just one. Did you say 4? No, just one. Just one. If I asked you the probability of drawing a diamond from a deck of cards, a couple different ways to look at it. How many cards are in a deck of cards? 52. How many of them are diamonds? You knew that it would be 13. And if you reduce that, you'd end up with somebody 1/4. Or you could just think about it in terms of how many different suits are there. 4, and they're equal suits. You have the same amount in one out of 4 of those. How about this? Let's go real crazy here. What is the probability of drawing any queen? Probability of getting a queen. How many cards in the deck? 52. How many of them would be queens? Zachary? How many queens in the deck of cards? 4. And you do have to reduce if you can, and this does reduce to 1/13. 1/13. Or we could do, what is the probability of one-eyed jack? You'd have to be a little card person to know that. How many jacks on a deck of cards have one eye? Okay. Either 1 or 2, I can't remember what it is. I don't know. Got that? We got to go at breakneck speed here. Blank piece of paper. Write down the word chance. I know you've asked yourself a million times, but today you will get the answer, ladies and gentlemen. What is the difference between probability and chance? There's a very small chance that Caleb will know the answer to this. Sir.
Chance is 7%.
Wow. How did you know that? Did we talk about this last year?
Yeah, I got it wrong last year.
What?
I got it wrong last year, so.
See, and that's an example of how getting things wrong helps you to get them right. Chance is the same as probability. But in percent form. And a good way to remember that is you always hear the weatherman giving the chance of rain, and it is always given as a percent. They will say there is a 20% chance of rain. Well, if you change that into probability, the probability of rain is 1/5. Which means if you looked at our little line table that it is unlikely to rain. Does that mean it won't rain? No, but it is unlikely. And weathermen are known to be wrong, so I don't know if they ask us for any more chance. Yeah, they could ask you the chance of that thing sign. Alright, blank piece of paper. This is the one you will get wrong. You get this one wrong too? Odds. As opposed to evens. Odds fits right in there with chance and probability, but it is. Joseph, you with me? If I asked you the odds of picking a boy out of a 7th grade class, how is that different than the probability of picking a boy? How is that different than the chance of picking a boy? Does anybody know? Do they think they know? Do they wish they do? Good. Odds, ladies and gentlemen, is the ratio of favorable to unfavorable. In other words, if you're going to the track to bet on the ponies, they give you odds. I wouldn't know, I've never really done that either. That means this, let's go back to our boy-girl thing. In 7th grade, there are how many boys?
8.
That's all.
Yes.
Yes.
How many girls?
14.
That's all. Okay. Let's look at it. Let's do probability first. Probability of picking a boy would be 8 out of 22, right? Favorable out of total, which is what? 4 out of 11. The chance of picking a boy would be changing this into a percent. 4/11 would be close to what percent? Somebody throw that out. You can get awful close. It's not going to be right, but it'll be close. 4/11 is close to what percent? Chase?
40%.
You'd be a lot closer than that. 11 times what is close to 100? 11 times 9 is 99, so we're not going to get much closer than that. What's 4 times 9? It's about 36%. Back to the odds. Odds is favorable, which means this. How many boys are there? 8. How many girls are there? That's the not favorable in more ways than one. That would be what? 8 to 14. That is your odds. Favorable to unfavorable. You do have to reduce it. It would be 4 to 7. 4 to 7 are the odds of picking a boy. Odds of picking a boy is 4 to 7. Got the difference between odds, probability, and chance? Favorable to unfavorable. I don't know if I'll ask you another question too much about odds, but I do want to test, so. Well, we could go back to this. Here, let's go back. Well, let's just draw a spinner. God bless you. Say you've got that spinner, and this time it is, well, let's look at this. God bless you. The odds of spinning an egg would be favorable to unfavorable. Favorable would be, how many A's? How many not A's? 3. The odds of spinning an egg, God bless you, is 1 to 3. Who's that? Oh boy. All right, ready? Blank piece of paper. And right on top of this one, sample space. Layton, are you reading what sample space is? What is it, Layton?
The sample space is the collection of all aspects.
When it asks you for the sample space of something, it wants you to give every possible outcome that you could give. For example, back to our spinner, our A, B, C spinner. If you're asked for sample space, let me give you the exact specific thing. Since sample space is a list, a set of numbers, you would write it like this. Sample space equals, anytime we do a set of numbers, you use my favorite mathematical symbol, which is a brace, and then you would list all the possible outcomes there are. The sample space for spinning the spinner would be A, B, C, and D. If I asked you this, let's say you were spinning this thing and you were flipping a coin, Abraham Lincoln? Did I do Abraham Lincoln? And I asked you for the sample space of that? Well, there's a couple different ways you can do this. You could do this. Let's do the coin first. How many different what different outcomes can you have when you flip a coin? You can either have, Grace, heads or, you can either have heads or tails. Well, after you flip the coin, what can you get on a spinner? Either A, B, C, or D, right? So I could get a head A, a head B, a head C, or a head D, or I could get a tail A, a tail B, a tail C, or a tail D. What would my sample space look like? Well, this is what it would look like, unfortunately. There's no pretty easy way to do it. Head A, head B, head C, head D, tail A, tail B, tail C, tail D. You have to list all 8 of those possible outcomes. Do they get any deeper into that? I don't know. Let's keep going here. One last one. What would be the sample space? Sample space of flipping a coin 3 times. Now, what is the way you can organize your thoughts on that? You pretty much have to do a tree diagram. Check out the tree. For the first flip, what are your choices? Heads and a tail, right? Then after that, your second flip, off of each one of the first ones, you're going to also get a head or a tail, right? And then what about the third flip? What are your choices going to be? Off of each one of those, you're going to get a head or a tail. Head or a tail. Head or a tail. Head or a tail. So if I asked you to draw up the sample space, by the way, there's no easy, good, right, or wrong way to do this. Here's what you have to do. You kind of follow the line down. Pick a different color here. Go to green. So here's your sample space. You get head, head, head. Sorry, I don't want to put a comma there. You get head, 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 or you get head, head, tail, or you get head, tail, head, or you get head, tail, tail. Then you go over to the tails first. Tail, head, head. Tail, head, tail. Tail, tail, head. And tail, tail, tail. And from this knowledge, children, the whole world opens up. Because if I asked you, what's the probability of getting a head, head, head? Now you'd be able to tell me. Somebody, anybody out there in the Emily, what would be the probability based on my sample space of getting head, head, head? 3 heads in a row. Well, first of all, how many different possibilities were there? 8. And how many of those probabilities were heads? Head, head. How many head, 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 head were there? Chase, help her out. 1. Thank you very much, which was just this one. There was only 1 of those. Good, good, good. How about this? What is the chance? Chance of getting head, head, head. Anybody out there in the wide world of sports, tell me what that chance is. Somebody. Please. Work with me here. Oh, look at Caleb's actually looking at something. Caleb, what do we get?
12 and 1.5%.
How'd you get that?
The paper you gave us.
Yes, you're welcome. Alright, and then, ladies and gentlemen, as a drum roll, what are the odds of getting head? Odds of getting head. Cassie Malis. Odds of getting head. 1 to, I'm sorry? Favorable to unfavorable. There you go. 1 to 7. It's favorable to unfavorable. Ones that are not there. Think we got that? Shall we keep beating the proverbial dead horse? At what point, Sarah Grace, did you lose interest? Go ahead, take it. Somewhere in the middle of probability. Now, go back because we're not done yet. Probability. Is this probability? No. Is that chance? Under probability, children. Go back to those notes because we have a couple things here. Just pick a spot there, Keanu. I'll get you there. Where was Connie? Does anybody know? I would say you're between those two gals over there. Under probability, children, under probability. We have two different types of probability. We have got theoretical probability and we have experimental. Did I spell that right? Is that how you spell experimental? That doesn't seem right. I-R-E? Who said it was wrong? It is experimental. Thank you very much. Somebody say that, Zach? Aaron, I believe you are next to Zachary. Lauren, I think you're next to Caleb. And Shannon, you're next to Brian. Does anybody want to speculate? Anybody want to speculate the difference between theoretical and experimental? Cassie was reading. Is wrong with something, Cassie? Yes? No? Lev?
Theoretical probability is analyzing the situation, and experimental probability is determined statistically.
Right, that's exactly it. Did you catch that? Say no.
No, we did not.
Theoretical probability, children, is mathematically what should happen. Mathematically? Anybody? Mathematically? Somebody that doesn't seem right.
Yes.
Mathematically, what should happen? Experimentally is what actually happens when you do the experiment. In other words, here's the difference. The probability, if you flip a coin, of getting a head is what? That's not very hard to tell me that. Somebody? Listen, we'll stay here forever. Huh? No, that's chance. Probability, fraction of that is 1/2. The theoretical probability when I flip a coin is that 1 out of every 2 times I get a head, right? That's theoretical. If I do it, when I do it, if I flip a coin 10 times, I flipped the coin 10 times and I got 7 heads, this is my experimental probability. Theoretically, I should get ahead 1 out of every 2 times, but when I did the experiment, it didn't quite get out. It didn't actually do that because has anybody ever flipped a coin and gotten ahead twice? I'm sure you have. Well, that doesn't fit with, theoretically it doesn't fit, but experimentally that's what happened. Now, before you leave, let me blow your mind with this thought.
Mine was
The more you experimentally do the simulation, like, okay, here it didn't match up, right? I got 7 out of 10. But if I would do this experiment probably 1,000,000 times, I'd be willing to bet that 500,000 or very close to 500,000 times you're going to get that answer. The more you do the experiment, the closer it will get to theoretical. In other words, it's really easy to flip a coin twice and get 2 heads. That's not very hard. But if you flip a coin 1,000 times and get 700 heads, that's not going to happen as often as that. Because the more you do the experiment, the closer this will come. Eventually, you will catch, these two will catch up. And you won't understand that later, but maybe when you get to be smart, you will. Off with you now, children. Off. Enough!